What is up, everyone? Derek here from DW Designs, and welcome back to the channel. We're going to be continuing on this sandrail part 3. We left off in the last video of me being very frustrated with the computer software, trying to figure out exactly what's going on. And I did some playing around with it, and I finally figured it out. We still had to get a grasp on things and get things going. Originally, we planned on sleeving in between. As you guys can see, I already cut out some big sections here. Already cut the section off that where the shock tower was and all this stuff that was going on in here. Part of the problem was that this sand car has already been repaired several times now. And how I know that is if you look right here at the very end of this tube, see if we can get that to focus. There's another tube that's inside there, which means it's been sleeved, which means it's been repaired already. And unfortunately, it goes all the way up into here somewhere, which means this whole entire front hoop here is compromised. I already talked to the client about it, and we've made the decision that we're gonna go ahead and redo this whole upper tube and do it the right way. And I also figured out too that this was also, believe it or not, made out of mild steel. Can you guys believe that or what? Which is causing it to buckle every time right there and break it eventually from all the stresses. So we're gonna be doing 1.5" 120 wall DOM steel the right way, all the way up through the front here. And we're gonna be cutting it off right here and sleeving it in here. And then this is all gonna be a new tube here. This is also gonna be new from here forward. So yes, we got a lot of work cut out for ourselves here, but it's gonna pay off in the long run. Let's head to the computer once more, and I'm gonna show you what I did differently. So what I did differently this time was I went in, added fillets to the tubes to connect them solid at that point. I did that to represent the welds on the one side, and I anchored it down in one spot too. And then we did the simulation, and it came out and it was all bent and cattywampus afterwards. So I'm gonna go back in there, and I didn't save it. I left it alone so that way I can show you guys. I did rebuild the tubing in Bentech, not from scratch, but just made some modifications and then transferred it into Fusion 360. So we already have another tube chassis in Fusion 360. We just need to input it into simulation. And I'm gonna show you guys how it came out without any tubing or anything. And it's mind-blowing. So we got Fusion 360 pulled up right now, and we're gonna go over here and we're going to open my file, which is just Sandcar front end. Well, that ruins everything. Well, you guys have obviously now just seen the simulation that I did. I didn't exit out of it. Yes, I know there's little things that are wrong with this. If you guys really start looking closely at this thing, you know, like the tubing's going through the bottom here, whatever. But so as you guys can see here, it buckled up there and bent this down. And basically that was what the original point was doing with just the shock mount and everything. But it obviously had a brace going in between, but we didn't add that brace in there just because I wanted to see what would happen if we did that. So this is what we're looking at here. These are the forces that we're looking at. I tried to put the arrow as close as possible to what the forces would actually be. And this was only with 1,000 pounds, guys. 1,000 pounds. Now, if I go over here and click on safety factor and put displacement, look how red that is right in there, and yellow, and then green, and then blue. The blue is gonna be more so in this safety line where it's, you know, it's gonna be okay. But obviously, this light blue is starting to torque and bend. So we can't have that. So what we're gonna do is we're going to enter design, back into design rather, and I want to create another tube that goes across here real quick, just to add extra measure, and then we'll simulate it again and see what happens. And then from there, we'll add some more tubes if it bends again, just to see what happens, because trial and error, right? So what I did to fix the problem we were having is, let me zoom in here real quick. You guys will see here, in this section right here, there's like a fillet right here. That's to simulate it being welded together. And I did that on this section here because this is where the problem was. Yes, I know there's a gap right in here, but I'm not concerned about it because I filleted that as well. So it's acting like it's welded, except it just got a gap in there. And I know this tube's supposed to go completely straight, but I haven't fixed that at all. And I figured it wouldn't cause a problem. So we're just gonna run with this because I know for a fact this isn't gonna cause a problem here. So what we're gonna do is we're going to go into create a sketch, and we're gonna select this plane here, and we're just going to draw a solid line from this point here, and I'm gonna put a tube going all the way across to this tube right here. We're gonna create that line right there. Yeah, it looks pretty straight. Now what we're gonna do is we're going to exit out of here. Finish sketch. Now we're going to go ahead and reiterate the bodies here, and we're going to create a pipe, which, guys, by the way, it's not called pipe, it's called tubing. Pipe is after a certain size. Pipe is usually measured from an inside diameter. From what I was taught, doesn't necessarily mean it was 100% true, but I was taught that it was inner diameter is pipe and outer diameter is tubing. So just keep that in mind, guys. Remember that for the future. Now this is gonna be 095 wall because this is what is, oh wait, no, I'm sorry. This is gonna be 120 wall because this is gonna be a new tubing that goes in here. And we're gonna hit select, right? Or enter rather. And now we have our piece here. Now what we're gonna do is I'm gonna come in here and I'm gonna hit F, and I'm gonna select this tubing here that goes around like that, and I'm gonna fillet it, and I'm going to put in 0.20, which is, about what a weld is as far as looks wise goes. I don't know if that's exactly true, but we're just gonna roll with that. Now we're gonna hit select F again. I'm gonna select that tube again, select that right there, and we're going to enter 0.20 inches again. And then there we go, we have our fillet there as well. And now what we're going to do is we're going to go ahead and, well, first of all, let's hit save. Let's just hit milestone, so that way we have something working with there. And then what we're going to do is, now this, keep in mind guys, is right by where the shock is. It might be slightly forward a little bit, but it's right in here somewhere. So we'll get close with what the simulation is gonna be. We're gonna go back into simulate. And of course, we need to undo this. So let's go back to design. Let's simulations. Okay, so let's finish results. Okay, here we go. So now we have it with this tube rather than no tube at all. So we're gonna go ahead and let's create a new study. Now it should, in theory, just work. Hopefully I don't have to go back in and change all this again. So we're gonna go local and hit solve. And we're going to wait for that to, oh wait, hang on guys. We gotta remake the mesh again. So let's go to here, or actually solve, and generate mesh real quick. So we got this mesh that goes across this tube now too, rather than just the original base model because we added an extra tube in. So we're gonna wait for that, and I'll see you guys in a minute. Okay, so we have our mesh generated here. Takes a few minutes for that to generate. So what we're gonna do is we're just gonna go ahead and click solve locally and solve and see what that does now. With this tube being attached there right in the middle, we can see whether or not it's gonna buckle right there in the same place or not, or if it's gonna break or shear right next to it. I'm hoping that all it's gonna do is bend in a little bit, which is what it was doing originally, and show me the stresses right there. And then if I could put another tube straight up and down from that point, I would love to be able to just do that and then work around everything else later. That would be the optimum thing, I personally believe, but we don't know until we simulate it, until we see what's happening, because like I said, guys, we want to know for sure this is going to work properly, and I couldn't stress that enough in the other videos. I just wanted to be done right. I could just place a whole bunch of other tubes in there and really make it bulletproof. The issue with that is then we start adding too much weight and unnecessary tubing in places that where it doesn't need to be, and it makes the car heavier for one, and B, may not look aesthetically appealing to the eye if you're looking at it. I know that aspect of it doesn't matter as much, but to me it still matters. So it's like building a trophy truck, guys, from scratch, or a class 1 or something like that. You want to build it as strong and as light and obviously as good looking as you possibly can. So that's where CAD software comes in handy, is you can do all kinds of things rather than trying to, like I said before, trial and error, take it out to the desert, break it, and then fix that problem, and then break it again, fix that problem, until you get to a point where you're happy that, oh, if it breaks here, that's where we designed it to break, kind of thing. And now and that's another thing we gotta cover too, is you gotta have breaking points somewhere in certain things. Obviously this shock mount can't be a breaking point, because this is what keeps the vehicle going and floating across the sand in the desert. So this can't be a breaking point. It has to be a breaking point elsewhere if we're gonna have a breaking point. So I just want to get it somewhere where we're happy medium, where we know it's not gonna break or shear off again, but yet it's gonna be, strong enough. All right, so the simulation is finished, and as you guys can see here, clear as day, it is just mind-boggling bending this thing, and that's only with 1,000 pounds, guys, which the front end of that sand car only weighs, probably 400 pounds or so. But even then, this is ridiculous. Like 1,000 pounds, that should be a lot better than that. So we're gonna go ahead and we're gonna hit finish results, and we're going to go back in to design. We're going to exit out of bodies real quick, and we're going to hit create a sketch on this plane. Let's make a tube here, right down the middle here. Now let's put our bodies back in place here real quick, and let's just select the point here and go straight down 90 degrees. But first, let's enter that there. Finish sketch. Get the bodies here once more again. Let's go back and pipe tool, and we're gonna go ahead, and that is ugly. Wow, is there a way for us to fix that? That's not entirely correct here. Let's undo that. Oh, see guys, it's off the plane there. Okay, so let's undo that, click our bodies again. All right, so we're somewhere right around there. So we're gonna go ahead and click. Oh, there's our tube right there. Zoom out here. Oh, I clicked the wrong plane. Right off of there. And go straight down to, let's see, are we even on the, nope, we're not even on the, see guys, this is where stuff gets complicated here. Let's cancel that. Create a sketch. Okay, we're gonna be drawing on this plane here. Okay, does that look correct? Let's find out. Yes, but we're in the wrong spot. But just for kicks and giggles, let's finish sketch here. Let's see if this will, no, that's not right either. Do this one more time. See what we can do here. All right, let's hit join. Now, I know guys, this wouldn't be considered correct at all. But let's just give it a try. Let's just see what it does, just to see what'll happen if we leave it like that. So let's try this again. See if we get anywhere close. Like I said, this is not perfect. I'm not planning on being perfect here. I just want to know, if I place a tube X, Y, and Z, is it going to hold? That's all I want to know, because it's all within the parameters of where we're going to be working in our constraints real life. I just want to see what the strength capabilities are. And now, mind you guys, this here, where my mouse is pointing, would actually simulate, like, let's just say you had a bad weld right here, or maybe just, I don't know, just think of worst case scenario. You have a small bad little weld here, it's not holding all the way. This one up here would obviously be solid, but it's not a good situation to be in. But we're not going to do that. So we're going to make sure that it's 100%. So I just want to see what it's going to do here. And if it doesn't do anything, then great. That would be totally awesome. If we need to add a couple more tubes, we'll add a couple more tubes. And I'll probably spend some more time off the camera doing this, if we need to add some more tubes after this, just to get an idea of what's going on, and then I'll bring you guys back in. So we're gonna wait for this stuff to load. I'm gonna bring you guys back after the mesh is loaded and the simulation has been done. So I'll see you guys in a couple minutes. As we got here, this is just bonkers, if that's even a word. Like, this is insane. Only 1,000 pounds, unless I put the wrong amount in there. It could be 10,000 pounds. If it's 10,000 pounds, then holy cow. With that being said, I know I'm gonna unveil to you guys what I'm gonna do to fix it. I am 100% confident that it's not gonna buckle or break again for what I'm going to do, just based off looking at the simulation software. But here's the kicker. That tube, even in CAD, helped a lot in comparison to without the tube. It was going considerably high in the bend, and with the tube it is now bending a lot less. But due to CAD, it's still, me not understanding everything, it's still bending too much in there. But we'll learn it as we go later on down the road. Is we're gonna add a tube right here in the middle, right about where the shock goes, okay? Not back here, not right here where the shock goes, because that's where most of the force is. And then we're going to back it from this tube right here into where the shock is. So we're gonna have 2 meeting points and then one going across. That's gonna be 3. So you're gonna have 1, 2, 3, 4, all right in that section, holding that guy solid in place, no movement whatsoever, and it should not break again. That's what my plan's gonna be. I'll see you guys in the next one.